Let's talk about the Pythagorean theorem or the Pythagoras theorem. According to the theorem, if we have a right angle triangle here, that is a triangle that has a 90-degree angle. Let's say the side here as the base B and the side here is the altitude A. And the longest side of the right angle triangle, let's denote it as C. This is called the hypotenuse. Now, according to the Pythagoras theorem or Pythagorean theorem, the square of A, that is A squared, and the square of B, is B squared, the sum of it is equal to the square of C. Okay? In other words, if we draw this, A squared is just a square that has a side of A. So this is A squared, or A times A. Side here is A, side here is A, so A times A is A squared. Now, this one, the B squared, is this square extending from our side B. Okay, this square, the area is B squared. And the side with hypotenuse C has an area of C squared. Now the theorem says that the sum of these squares A and B, side B and side A, is equal to the square of side C, this one. Now I'm going to demonstrate that using geometry or some shapes. Let's prove the Pythagorean theorem using this shape. If you observe, we have a right angle triangle here with base B, altitude A, and hypotenuse C. So notice that we have a square here with side A. Alright, so the area of this is A squared, and this one we have a square, bigger square here with side B. So the area of this is B squared. The total area of this shape is A squared, which is the area of this smaller square, and plus the area of the bigger square with side B, that is B squared. Now what we're going to do next is we're going to move this right angle triangle to the right side. Take note, we start from here and we're moving it here, so that is A units away. The result will be this triangle here. Okay? Now notice that this is altitude A as well, and this one is the base B, and this side here is C, and this side here is as well is C. Okay, there you go. Now I'm going to reconfigure this shape. Okay, I already pre-cut this. I'm going to move this up here. And this one, I'm going to move this over here. Let's check this shape out. So now this side here, this is a right angle triangle. This is the right angle triangle. This is the altitude, and this is the base, and this is the hypotenuse C. So this has side C. Take note, another triangle. This is the altitude and the base, and this is the hypotenuse, and we wrote that earlier, so that is C as well. And this one, this side here, we wrote it already earlier, that is C. And this one is also C because it's taken from this one. This one is the hypotenuse here. Okay, so there you go. So we have this shape with side C, 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 C. So that's a square with side C. In other words, the original shape A squared plus B squared is now equal to this square here of side C, C squared, and that proves the Pythagorean theorem. Let's prove the Pythagorean theorem using another way. So we have a right angle triangle here with base B, altitude A, and hypotenuse C. Now if you recall, the area of a triangle is equal to 1/2 base, the base is B here, times height, and the height is A here. So we have 1/2 BA, or let's rearrange that into AB. I have 4 identical triangles here. I made 4 of them. So the total area of these 4 triangles is now 4 times 1/2 AB. And that gives us 2AB. Alright, now I'm going to rearrange these triangles to form something, to prove the Pythagorean theorem. Okay. So we originally have 2AB as the total area of the 4 triangles. I'm going to put this triangle like this, and then the other one like this, the third one like this, and the fourth one like this. So if you see, we form a square, and let's look at this, let's investigate this square. Now this side here is, okay, this side here is C, okay, this is C, side is C, side is C, side is C. All of these are the hypotenuse. So this square is, the area of it is C squared. But we have a square hole inside, so we're going to take that away, so that what we're going to get is the total area of the 4 triangles. So we're going to remove this square hole inside. Now if you look at it, this side here is B, this is the base, and this is the altitude. So the side of this square hole is B minus A. So the area of it is B minus A squared. So that's what we're going to subtract to. That's what we're going to subtract to our C squared to get the 2AB. Okay, let's rewrite it here. C squared minus, is that again, B minus A squared. This is the square hole, and this is the big square. Okay, that gives us the 4 yellow triangles here. Okay, let's compute it now. We have 2AB. This one is C squared. And let's use a little bit of algebra here. So that is square of B. It gives us B squared. You multiply A and B times 2. So that gives us minus 2AB. And then we square the negative A, that is plus A squared. Then we do the distribution. Okay, the left side is 2AB, right side is C squared. Distribute the negative sign, that's negative B squared. Negative times negative is positive 2AB. Negative times positive gives us negative A squared. Now let's going to subtract like terms. Minus 2AB, here minus 2AB. I'm going to move this C here, okay, or B squared and A squared here. Take note, we can take this away already. We'll add plus, anyway, this one, minus C squared here. I have minus C squared here. Alright, so we have on the left side, we have minus C squared, negative C squared. This one will cancel out. This is already 0. So what is left on the right side is negative B squared minus A squared. And we're going to multiply both sides by negative. Okay, negative times negative, that gives us positive. And this one is positive as well. This one is positive. Plus a squared. Or we can rearrange that. C squared equals a squared plus b squared. And that proves the Pythagorean theorem.